So now we're just taking the laws of the exponents and we're adding some complexity to them. So with a, we have this exponent of 1/3 that's outside the bracket that needs to get applied to everything inside. Well, but what about that 8? That 8 doesn't have an exponent. It still needs to get applied to the 8, the a, and the b. So what we'll have on a is 8 to the power of 1/3. We'll just attach the exponent there. A to the power of 3 times 1/3. And b to the power of 6 times 1/3. A little bit of simplifying necessary. If we look at 8 to the power of 1/3, well, 1/3 exponent, same as a cube root. The cube root of 8 is 2. With the a exponents, 3 times 1/3 is 1, so we'll just have a. With the b exponent, 6 times 1/3 is 2, so we'll have b squared. b, we don't have any multiplying of exponents to do, but we do have adding of exponents. The 3/2 on x with the 1/2 on x. Do that off to the side. 3/2 plus 1/2, 4/2, which would simplify to 2. So with b, we get x squared. Calculation's a little bit easier on the y. We have 2 plus -1, which would give us 1. So we'll just write y. C, we're going to be subtracting exponents on the dividing, but we have the 4 and the 2 that don't have exponents on them. We'll treat them like regular numbers. 4 divided by 2 is 2. Subtract the exponents on the a's. We would have -2 minus 2. Do that to the side. So we're given an exponent of -4 on the a's. With the b's, we'd have 2/3 minus 1/3, which would give us 1/3 exponent on the b's. Just flip the page to deal with D. Copy out the question again, just so we have it handy. 100a on top. 25a to the 5th. And b to the -1/2. Make that look a little nicer. With an exponent of 1/2 on the outside. This exponent of 1/2 here is going to have to apply onto the 100, the a, the 25, the other a, and the b. If the exponent's outside a bracket, it has to apply to everything inside. So we'll get 100 to the 1/2 and a to the 1/2. Those didn't have exponents, we'll just attach it on. Same thing with the 25. Go off to the side. For the bottom a, we have to do 5 times 1/2, which is just 5/2. So we have a to the 5/2 on the bottom. With the b's, we already have -1/2 multiplied by the 1/2 outside. Gives us -1/4. Taking a look at the numbers, 100 to the 1/2. Again, 1/2 is the same as a square root, so that would become 10. We have a to the 1/2 with it. 25 to the 1/2. Square root of 25 would be 5. a to the 5 over 2 and b to the negative 1/4. Now we have a 10 and a 5. No square roots. Those will reduce to 2. Next to that we have the a's. We're dividing, so we subtract exponents. 1/2 minus 5/2 give negative 4/2, which is reducible to negative 2. So we have a to the negative 2. And there's no b's to simplify with. So they're just going to stay as is. But you have to keep in mind, where were those b's to begin with? On the bottom of a fraction. So they need to stay in the bottom of that fraction. So that's what our answer would look like.